Hello everyone, I hope my screen is visible and I am audible. Okay. Please confirm in the chat box. In my, is my screen visible and am I audible properly? Okay, Sunny, thanks. Okay, so uh, the today's topic for discussion is dynamic programming. Okay, so what is uh, programming and when do we use dynamic programming? Uh, Let me start by taking a simple example. Okay, taking a simple example. Here we have, for example, uh, if like my question is to count how many vertical bars are there. So even a 4-year kid would say that there are uh, 6 vertical bars. Okay. So what you did, you counted each bar one by one. Okay. Now just put one extra bar here. Okay. Now I ask you how many bars are there. So you would say there are 7 bars. Okay. Now this time you didn't count each bar one by one. Okay. So you had memorized the result of the previous problem, and you use that in the next bigger problem. So simply speaking, that's what dynamic programming is. We try to we try to memorize the result. We try to memorize the result for a smaller sub problem, okay, that we have already solved. That we have already solved. Uh, so I would be discussing. There are two kind of approaches to approach any DP problem. Uh, the first one is uh, bottom-up approach. Okay. And the second one is top-down. Okay. So in this approach, what you do is you uh, like I would be discussing this abstractly. In this kind of approach, what you do is you build the solution from the basics, like from the scratch. Okay. And in top-down approach, you start from the top. You start from the top, and then you uh, build the solution. And in bottom-up approach, so uh, there is a confusion that often like people say that bottom-up approach is always uh, iterative approach or using loops, and top-down approach is a recursive approach. But that's not quite true. Like you can also implement bottom-up approach using recursion, and you can implement top-down approach also using recursion. So these two are different ways of seeing things. So let's start by taking a simple example of Fibonacci that we have already discussed in divide and conquer. Let's see how calculating Fibonacci works. So if you remember, the formulation, the recursive formulation for Fibonacci is kind of like this. f of n equals f of n minus 1 plus f of n minus 2. And the base condition is when n is equal to 1, f of n equals 1. When n is equal to 2, f of n equals 1. So these are the base conditions. So what is Fibonacci? Let's revise it again. Fibonacci is nothing but a series in which the next term is the result of summation of previous two terms. For example, we have first term here, second term here. Okay, this is n. This is n here. So when n equals 1, the f of n, this is f of n. F of n equals 1 when n equals 2. According to base condition, f of n equals 1. When n equals 3, f of n equals 1 plus 1, that is 2. When n equals 4, f of n would be equal to 2 plus 1. Okay, 2 plus 1, that is 3, and n equals 5, f of n would be 5. So, so let's see how this recursive approach is working. When we want to find f of n, we make two calls for f of n minus 1 and f of n minus 2. So what happens is, uh, for example, we need to find the 8th Fibonacci term. So what will happen? This is f of 8. Now this will call, okay, f of 7 and f of 6, because f of 8 minus 1 is 7 and f of 8 minus 2 is f of 6. Okay. Now f of 7 will call f of 6 and f of 5. Okay. F of 6 will call f of 5 and f of 4. Okay. F of 4 will call f of 3 and f of 2. F of 2 will call f of 1. Okay, it won't call anything because 2 is our base condition, so our function will return from here. Okay. And f of 3 will call f of 1 because 3 minus 1 is, 3 minus 2 is 1, and f of 2. 3 minus 1 is 2, and 3 minus 2 is 1. So these two are base condition because the first and the second, when n is equal to 1 and n is equal to 2, we already know what is the answer. So from here, what we will get? 1. Here we will get okay. From here we will get 1. Here we will get 1, and this will return, f of 3 will return 1 plus 1, that is 2. F of 2 will return 1. Okay. F of 4 will return 2 plus 1, that is 3. F of 5, okay, there will be another tree for f of 5. F of 5 will return, we know that f of 5 returns 5. And then f of 6 will return 5 plus 3, that is 8. I hope this is clear, like this is very simple. Okay. Now you can see that here we have calculated f of 6, that is 8. Okay. Now to calculate f of 8, we need f of 6 as well as f of 7, and to calculate f of 7, we again need f of 6, right? So if we try to implement it using just simple recursion, what will happen? uh, there will be like uh, multiple overlapping calls. Like we have already calculated f of 6. Okay. Again, here we are calculating f of 6. So that is gonna take additional time, additional amount of computation, because we are again calculating f of 6. So a better idea is, once we have calculated f of 6, uh, can't we just store f of 6 in some array, and whenever we need again f of 6, we won't be calculating it again. We will just refer to the array and ask for the solution for that sub problem. Okay, so this is our problem. Okay, and these simple problems are sub problems. So what we do, once we calculate f of 6, we put the answer in an array, and then when we need f of 7, f of 7 will ask for f of 6, and here f of 6 won't be calculated again. Here we'll just refer to our array, that is uh, we'll refer to our array, and we'll just look into it, what the solution for f of 6 is. Okay, so this will directly return it because we have already calculated once. So how do we implement it? Let's see. How are we going to implement it? We have a function in fib. Okay, and this takes a number as a parameter, and we have an extra array. Okay, we have an extra array that will uh, store the results that are already calculated. So we call this array DP. You can call it anything, doesn't matter. So what I do now, let's write simple recursive call for uh, so what is Fibonacci of n? That is answer equals fib of n minus 1 comma dp plus fib of n minus 2 comma dp. It's simple. Now what we do, we write our base condition that if n is equal to 1 or n is equal to 2, we, do, we just sorry, we just return 1. So this was our I haven't yet used memorization. I'm just showing you simple recursive approach, and then what we do, we just return the answer. Now here we aren't storing the results that we have calculated. Now we know that answer contains answer is Fibonacci of n. Okay, so what we do, uh, we just we can write something like dp of n is equal to answer, and then we'll return answer, and we'll check here if dp of n is not equals first here what here I am defining my dp array. Okay, 2 plus 1 This is the size, and I want each cell to be initialized with -1. So I want to print fib equals 8, fib n comma b. So initially the DP array. Okay. Initially, what we have an array of size um, n plus 1. So we have kind of like if n is equal to 8, then we have uh, an array of size 9, and each block is filled with -1 initially. Okay. So what we do, whenever we calculate the answer for a particular value of n, we just store it in the array, okay, at that particular position. For example, if I have already calculated, let's see, 1, 2, 3, 4, 5, 6, no, 7, 8, and 9. Okay. Now, now, uh, once I calculate the answer for 6, what I do, I just replace it with the answer that was 8. Okay. Here, f of 6 was 8. So what I'll do, I'll replace like -1 with 8. Means I have already calculated the answer. And uh, when I would be needing f of 6 again, what I'll do, I'll just refer here, and I'll directly get my answer. Okay. So what I do, like if dp of n is not equals to -1, this means that I have already calculated my answer. Okay. And I have it in my DP array. So what I need to do, I just need to directly return DP of n. So see how it works. Okay, so we have uh, f of 8 equals 21. So f of 8 is 21. Let me verify it again. So 8, 6, 7, 8, 13, and yeah, 21. Okay. So f of 8 is equal to 21. So I hope this till this it is clear. I just use the recursive approach, and I just memorize this this process is called memorization. It, uh, sorry. It means that uh, we are storing the calculated result. We are storing the calculated result in an array. So a question is that what will be the difference in case we use DP or not? As this code is generally the same in case we use only recursion. I'll show you. Let's see. Let's see what difference makes. Okay. For example, I comment this block. Okay. Now I'm not using the. I'll comment this also. Now this is simple recursion. We are not using DP, okay, and we are trying to calculate 20. Let's see the time it takes. Okay, it won't take much time, but let's see for 35. doesn't take much time. 40. If I, so you can see the time it takes if I'm not using DP. Now I'll just simply move it. And I'll rerun it again. Okay. See, you can see the difference clearly. Like the difference is quite large. Okay, the code that was without DP that took 9 point something second, and this took only 1.7 second. So the difference is quite large. Why is this happening? Simply because uh, we are recalculating the things that we have already done. Like without DP, what we are doing, once we have already calculated f of 6, we are not using it again. We are again calculating f of 6. Uh, and it is happening for not only f of 6, it will happen for every number that is overlapping. Like here also we are calculating f of 5. Okay. Now, when this call will occur, here also we will be calculating f of 5. So that will take obviously a greater amount of time. If you for n, that's gonna take approximately O of 2n. Okay, but when I'm using DP, it's taking O of n. Okay, I need to be more sure on this, but you clearly saw the difference, right? So I hope this was clear. If using if makes it DP, without it, it was recursion. Yeah, without it, it was simply recursion. We were without it, with without this, what we are doing, we are storing the results, but we are not using it. Okay, if I comment this out, now what we are doing, we are storing the result. Okay, but we are not using it. This blocks ensures that we are using the stored result. Okay, so this means that if dp of m is not equals minus 1, means that we have already calculated uh, 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 the result somewhere previously, and now we need to directly access the result and return it. If we haven't, then we'll go for this. I hope this is clear. Does the yeah, time complexity changes. DP is optimization over recursion. Yeah, this is recursion, not DP. Uh, this is recursion plus memoization. So, uh, above, can you make it more clear? Like, okay, okay. Vaibhav. So let's see next problem. Next, we have staircase problem that is similar to, like we did staircase problem in divide and conquer. Okay. No, should we do it again or not? Okay. Okay. If there will be time, we'll discuss it. Let's go to another problem. That is this. Okay. You have 5 minutes. Okay. Please don't see the solution. I'll just ask you to like read the problem. Okay, and think on your own. Then we'll discuss it. Please don't try to see the solution. Paste it in the chat box. This is a good problem, a French pairing problem on GFG. So the question says is, uh, we have like uh, n friends, okay, and each one can remain single or can be paired up with some other friend. Okay, the we need to find the total number of ways in which friends can remain single or can be paired up. For example, we have n equals 3, then we have a possibility that all three can remain single. Then we have a possibility that one can remain single and other two can be paired up. Then the first two can be paired up and three can remain single. So we need to find the uh, total number of ways in which we can generate this kind of combination. Subset finding idea can be used using recursion. Uh, don't do it. Like this problem can be solved really simply if you think more carefully. I would recommend you to make this kind of tree and observe the tree. Okay, make this kind of tree and try to observe the tree. You don't need to generate subsets really, Arpan. You won't be needing that. Meanwhile, if you have any doubt, you can ask in the comment box, chat box. Let's see. Uh, let's take an example. Like if n is equal to 4, and we have four friends, A, B, C, D. Okay, n is equal to 4, and we have four friends, A, B, C, D. No, we have four possibilities, right? If we choose A, we have four possibilities. What are these? Either A can remain single, okay, then we will be left with three friends, B, C, D, right? Or A and B can be paired up, then we will be left with two friends C, D. Okay, A and C can be paired up, and we will be left with two friends that are uh, B and D, right? And then we have A and D can be paired up, and then we will be left with two friends B and C. Okay. Now this was a bigger problem. This is a smaller sub problem if you observe it carefully, right? This is another same kind of problem. Okay, let's see how to solve this. Now from here, let's see for this branch of tree. Okay, for this branch of tree, we have again two possibilities. Okay, one possibility is C can remain single, and we will be left with one D. D can remain. Sorry, if we are working on just C. Okay, let's suppose if we are working on just C, then we have two possibilities like C can remain single or C can be paired up with CD, and then we will be left with zero people, and the string will be empty, kind of this. Okay, and so I hope this is clear what is happening. Initially we had four friends. For A we had four choices. A can remain single, then AB can be paired up, AC can be paired up, AD can be paired up. If A remains single, we have three friends left, three. So I represented it like this, 3 slash PCD. And if AB are paired up, then I have represented like 2 slash CD because CD are left. Okay. Now from here we have two possibilities. Either C can remain single, then we will be left with only one person, that is D, and D has no choice but to remain single. Okay, so this will be something like this. Okay, if you follow any branch of tree till the base case, this is the base case, you will get one way. Okay, this is, if you follow this, okay, if you follow this is one way. What is that way? That is AB comma CD. If you follow this branch of tree, okay, that is another way. What is that? AB comma C comma D, isn't it? This is simple, right? So what are we doing? We are just for each person we are seeing all the possibilities. Okay. Now see, can't we just like can you observe that what is happening here? If only one person is there, okay, and we need to find the total number of ways, what will be the answer? That will be one. Okay, we have only one possibility that uh, that person will remain single. That person won't be paired up, right? Okay. If we have zero person, then what is the total number of way? Uh, so this is our base condition. Okay. So like if we have 0%, then also there is one way. Okay, we can do nothing. Okay, So if we have two, yeah, someone unmuted. F of n equals f of n minus 1 plus f of n minus 2 plus 1. No, it's so what is happening here? Just see, does it really matter here? Is it CD, BD, or BC? We need to only find the number. Okay, we are only uh, bothered with the number. Okay, 2. It doesn't matter. Okay, uh, so isn't it something like we had 4 friends? I called for 3, then I called for 2, but I multiplied this with 3 because here I am doing it 3 times. Once for this, for this, for this. Okay, and for this we have only one call. So a recursive uh, formulation can be something like f of n equals to f of n minus 1 plus n minus 1 into f of n minus 2. If you observe this branch, okay, this branch, what is happening? Uh, uh, this is occurring once, so okay, for 1 we have this, and this is occurring once. I mean 2 minus 1 time, that is 1 time. Okay, uh, if you observe it here, what will occur? What will happen? Uh, Now we are taking B. Okay, now we are considering B. If we are considering B, then we have probably 3 choices. B can remain single, B can be paired up with BC, B can be paired up with BD. Okay. So we are left with here 2 slash CD, right? Here we are left with, if we take BC, then we are left with 1 slash D. Now you might be able to see there is something overlapping occurring. We have already calculated this, and again we will be calculating this, isn't it? We have already calculated 2 slash CD here. Okay, and again we need to find 2 slash CD. Okay, so this is kind of overlapping, and here also we are, if we are taking BD, we are left with 1 slash C. So if you observe carefully, you will find that these like ABCD, they don't matter. Like what matters is the number. Okay, for 4 we have choices like uh, f of 4 can be written as f of 3 plus, there are like 3 calls for f of 2, so we can write like 3 into f of 2. Okay, if I ask for f of 3, this is 3. Okay. If I ask for f of 3, then what will be the answer? One call for f of 2 and 2 call for f of 1, isn't it? I hope this is clear. So like this is the general recursive formulation that you can observe here. Okay, so what is happening? If we need to find f of n, we are just doing f of n minus 1 plus f of n plus n minus 1 into f of n minus 2. Okay. So for this also we can just write answer equals f of n dt. Yes, let's wait, let's wait. F, okay. Then we add m minus 1 into, okay, we are base condition at n equals 0 and n equals 1. We are returning 1. So I hope this is clear. Okay. Okay, yeah. Or we can write our base condition something like when n is equal to 1, we can return 1, and when n is equal to 2, we can return, let's see what we need to return when n is equal to 2. For example, if we have AB, then either A can remain single, so we can do something like AB, or A comma B, or AB. So we have two ways. So we can return 2. So this looks quite more realistic than taking n equals to 0, although both will work. So, but here I have taken n is equal to 1 and n equals to 2 as base condition at the constraint. Okay, so we can practice this here and we'll try to submit it here. Let's see if this works. Should work. I hope this question was clear. Okay, so okay, n is here greater than equals to 1, so n can't be 0. So no problem. This formulation for DP, it would remain same. Now, what we are doing, should work. Okay. So the problem is we need to take this mod. Yeah. And do something like so answer can be large. So I'm changing the return type to long. Okay. This would be board. That should work. Let's see. Okay. Anyone is able to figure out what is wrong here? Please let me. It should work, but so this worked. I hope this is clear to everyone. anyone has any problem or doubt, you can ask, or we can move to the next problem, that is 01 knapsack. Okay. So I hope this was clear. Like this was a very simple problem. So, so this is a problem. Like we are given uh, two arrays. Okay. One array contains weights of objects. Okay. Weights of various objects, and we have another array containing values of objects. Okay. And we need to maximize the value, that we need to choose objects in such a way that the value, the total sum of the value is maximum, and the weights should be within given limit. Like for example, W is the limit, then the total weight should be uh, W. Like for example, W1, W2, W3, and so on. And we have V1, V2, V3. So the question is that we need to select the objects in such a way that the values should be, the sum of all the values of all the objects should be maximum, and the sum of all the weights should be less than W. Okay. For example, this is an example. So here value is 60, 100, 120. Weight corresponding to zeroth object is 0. First object is 20, and second object is 30, and the maximum weight is 50. So the question is, like we need to select objects such that the uh, total sum of the value is maximized, and the sum of the weights are less than W. So so you may take some time to think upon this. So here the solution is that we will take the first and the second object, that is with objects with value 100 and 120. Then the value will be 220, and the weight will be 50. That will be less than equal to 50. So the main objective is to maximize the value. Okay. So this problem is famous. It is known as 01 knapsack problem. So okay, I hope this is clear. Let's take this example only. We have as Values are 60, 100, and 120. Okay. So, and the limit is 50. Okay. So, for each object, okay, we have two options. Either we can include that, or we don't include that, right? So let's suppose this is our index, okay, ID, okay, 0th, first, second, okay. So so for the 0th object, currently the maximum weight is the uh, the maximum weight is 50, and we are at 0th index, okay. So for this, we have two options. Either we can include it, okay, or we don't include it, right? So if we include the first object, then what will the limit for the weight will reduce, right? Because we have already chosen the first object that was with weight 10. So my index that will give me a value of 60. The first object is giving me a value of 60. So for example, here I am writing the values. Okay, I'm not writing the index. So currently I have the value is 0. So for example, I choose the first object. In the this this arrow is I mean the right side is for choosing, okay, and I'm making left side for not choosing. So I choose the first object, then I will get a weight a value of 60, and now the weight limit reduces to 40, okay, because the weight of the first object was 10. Now for the second object, I have two choices. Either I can choose it or I don't choose it. So let's suppose I choose it. Okay. Now the what will be the value? The value will be 160, and the weight will be weight limit will be 20. Right. Now for the third object, I can see that the weight is already 30 and limit is 20. So I can't choose the third object, okay. So the maximum value that this branch can give is 160, okay. Now now if I don't choose it, okay, if I don't choose the second object, so what will happen? If I don't choose it, then nothing will happen, okay. I don't use the second object. Now I go to the third object, okay. Now here I have this level is for the first object, okay. This level is for the first object, this level is for second object, and this level is for third object. For third object, I have two choices. Either I can choose it or I don't choose it. So my weight limit is 40. If I choose it, the weight limit becomes uh, 10, and the value becomes 120 plus 60, that is 180, right? Now I have no objects left. So this will return 180. If I don't choose it, then I have no objects left, and this will be kind of something like 60, 40, and this branch will return 60. Okay. Now the maximum of 60 and 180 is 180. So this will return me 180, and this is returning me 160. So I want to choose the maximum of both. So this branch will return maximum of 180. So this is when I choose the first object. Let's suppose I don't choose the first object. Okay. So what will happen? If I don't choose the first object, now I'm at again this, and here I have two options: either to choose the second object or to disregard the second object. If I choose the second object, the value I'll get is 100. Sorry. The value I'll get is 100, and the of the object was 20. So the limit will reduce to 30. Okay. Now this was for the second object. Now for the third, I have two choices. Okay. Either I can choose it or I don't choose it. So if I choose it, what will happen? The value I'll get is 220, and the weight limit is 30 minus 30, that is 0. So I have used up all the weights that was available. And if I don't choose the third object, then this will be this will remain something like this, and then I'll choose the maximum of both. Okay. So the maximum of this returns 100, this returns 220. So the maximum of both is 220. So this will return 220. Okay. And for example, this also returns something, and the maximum of both will be 220. And then at this level, I'll be returning the maximum of 220 and 180. So the maximum of both will be 220. So that's how my answer is coming. Okay. Hope this is clear how I am making the tree. Okay. Okay. If you have any doubts, you can ask me. Uh, we can like jump to the coding part. So what we have an array of weights, an array of values, and I have the maximum limit and I'm iterating. So I have an index. So I won't be using DP now. Like I'll be after I write the solution, then I would be memorizing it. So now what we do? Let's suppose if my index becomes greater than the size, then I will return 0. Okay, because I or greater than or equal to. Sorry. Then I'll return 0 because I have gone through all the objects, then only my index is becoming greater than uh, size. And then for a particular ID, right? For particular ID, ID is index. Okay, we have two options, including, excluding. Okay, now if I include that object, uh, if I don't include that object, then that will be nothing but maps. I'll be making a recursive call, pass the weights, values, and I'm not including it, so I won't change the weight, and I'll just go to the next object. Means I'm increasing my index with one. Okay. Now, if I don't include that, if I include that object, then including will be knapsack weights values weight minus of ID, because I need to decrease the weight by that the value of that object, the weight of that object. So I'm doing this. I'm passing this to the next level. So plus one, and if I'm including it, then this will become including equals. I'll take the value of that object plus this. Okay. I'm counting the value of that object. Now I can include only if this is greater than 0, isn't it? I can include it only when this is greater than 0. So I write it, and then I'm returning the max of including or and include excluding that object. Now for this I'm doing for particular index. Now the recursive call will manage everything on its own. Okay. That's clear. So what I've done, I've first I've excluded that object, then I've just passed, like I've just gone to the next object without doing anything. So this this function returns me the maximum value if I exclude that object. Okay, and this function, this will return me, this will give me the maximum value if I include that object. So this I'll get from uh, okay, I had something like 10, 20, 30. Okay, and then I had 60, 100, and 120. So at this particular level, I had two choices, either to include it or exclude it. And then I asked, like I had faith on my recursion, and I asked for the answer from for the next level. So this is working like this. Now this should work. Now I want to memorize this. So what I need to do, I'll just see. Here, two things are changing. Okay, the weight of the the states that are changing are W and ID. Okay, with each call, these two are changing. Okay, so I need to store for each particular weight and index. I need to store the answer. Okay, so I can do something like ID equals to if this is equal to, if I have already calculated for a particular weight and that index, if I have already calculated the answer, then I will just return the answer. So I hope this is enough. Then I need to. So here the DP vector is two-dimensional, not just one-dimensional. Why is it two-dimensional? Because uh, at each level, see, uh, if you look at the tree, okay, if you look at this tree, here at each level, okay, uh, see, for this I had 0 comma 50, but the weight was 50, but the index was 1, right? But here uh, the weight is 50, but the index is second. Okay, here also 0 comma 50 will be there, and but the index will be third. Okay, so the state, there are two states, weight as well as the index, right? So I need to consider both. If you look at this branch, then what is happening here? Here the weight is 40 and the index is 2, and here the weight is 40 and the index is 3, right? So that's why I'm creating to the array, and like for that particular weight and corresponding index, I'm uh, storing the answer. So, if you have any doubt, you can ask me meanwhile in the chat box. So yeah, Hope this question is clear. Like, okay, I'll correct it afterwards. Okay, I'll look at it afterwards. I hope the concept was clear, and you can ask your doubt if you have any. Okay, so let's take one last simple problem, the staircase problem. That is similar to the Fibonacci. Like we did this in divide and conquer too, but here we'll be just using DP. Okay, so the problem is very simple. You have a staircase, and at each level, okay, like you are at zeroth level, and you need to reach here, okay, or you are here, okay, doesn't matter, like you start from bottom or top, the answer will be same. So you are here, okay, and from here you can like take uh, either a step of one down, or you can take either a step of two down. Okay, so so you you need to find the total number of ways to reach the bottom. So in divide and conquer, we saw that the recursive formulation would be something similar to DP. That would be f of n equals of n minus 1 plus f of n minus 2. And this is similar to Fibonacci, and you just need to memorize the result, okay, and you'll get the answer. So I'll just recommend you, since we are already at 7:30. I'll just recommend you some problems to try on your own. Then we'll again have a second session on DP on Wednesday. Okay, Wednesday at probably 6 p.m. So that will be taken by Sonia Bhaiya. So meanwhile, you should try these problem on your own, like with, uh, unbounded knapsack. Yeah, about staircase. We just discussed this. Okay, staircase. Like we already did this in divide and conquer, right? Here, the difference is you will just need to memorize the sub problem. Okay, so I'm not telling you this because we already did Fibonacci, and the formulation is same, right? So I don't think it is needed. Then we have longest increasing. Series, and just try to Google these problems. These are some standard DP problems. Then then we have see once you are able to do this, try doing longest, okay, by tonic subsequence. Um, yeah, by tonic subsequence. and try to study this. So please try this on your own. We already discussed knapsack, so this shouldn't be much hard. Okay, for you, for unbounded knapsack, then you can try these two. Like once you solve longest increasing subsequence, you just need to observe things, and then this will be a cakewalk. Okay, by tonic subsequence. Okay, and this is a standard problem. So, so if you have any doubt, you can ask or done for today. Okay, thank you, Weber. So you can leave now. Yeah. So bye everyone. Good night.